Welcome back to Building Blockly. In the last video you saw me fumble around trying to get a library built, and at the end of the video I said I would be going to this tutorial here on Learn. Close that tab. That shows you how to build a library based on work that you did, and I followed this. So I'm going to show you where I left off, or where I ended. Let me minimize this window. It's not letting me minimize it. There we go. And so here is what I've done. I've actually changed it. So where I was just building a library for the digital potentiometer, I realized there were some other functions in Blockly that I have been meaning to get wrapped up into a library too. So what I've done is I've created just an analog IC library that's a little more generic. And inside of here, just following the tutorials, I've got it named properly. I've got, for instance, my functions for the digital potentiometer are right here. I've also added functions that I already had written up, but just again wrap them into the library for the ADC 0831, which is a single channel digital analog converter. And then functions we had for the MCP digital analog converter series, and then some functions that allow for a settable VREF, and then basically just the forward declarations and everything documented inside of here. And again, this is all explained in that tutorial. So I won't go a whole lot deeper other than to say I'm going to go ahead and quit Simple IDE here since I'm done with that work. And if I go back to my documents, first I'm going to go into Simple IDE, and this is the project right here. What I'm going to do is I'm going to move it inside of Learn first, and now inside of Learn I'm going to move it inside of Simple Libraries, and inside of Simple Libraries, I'm probably doing this the more complicated way than is necessary, I'm going to move it inside of Convert. So once I open up Convert, you can see we've already got some A to D stuff going on here. This just adds to that collection. So now I have my custom library inside of my Simple Libraries folder. So that's there. Let's go back to Documents. And remember that our projects are right here. So now what we want to do is we want to make blocks to go along with that. So I'm going to go back to Firefox, and if you follow this tutorial, it actually creates documentation for your library. So go ahead and open a new tab, and I'm going to go File, Open, and let's go to Simple IDE, Learn, Simple Libraries, Convert, where I put this, and here's my lib analog IC, and then I have the documentation right here. So if I open that up, now I can actually see my named constants and my functions that I get to go along with this. We're going to need this to create blocks that then write these functions. So we're going to leave this here, and now let's go to Visual Studio Code. We haven't set this up yet, other than to say hopefully you've downloaded it. If not, pause it. Go ahead and get Visual Studio Code for your system. And when you open it up, you get a welcome splash screen. You can either go add folder to Workspace or add Workspace folder right here. So let's go ahead and do that. And let's navigate to, just to make sure we're all in the same place. Let's start with our documents. Go Projects, BlockyProp Developer, and Source. So go ahead and click on Source here, and then that's the folder we want to add. All right, so now let's go ahead and we're going to save our workspace as BlockyProp app, or we'll say block developer. There we go. Save that. And so now we've got our workspace, BlockyProp developer. And these files are the ones that make up BlockyProp. So we can go ahead and close this welcome tab here, and let's make this a little bigger. To make our own blocks, there's a few files that we need to edit. So let's start inside of here. So most of the meat of this is inside of this Blockly folder, and then inside of generators. There's a few things we're going to need outside of this. Specifically, we're going to we might need to monkey with the language file. I'll show you what that is about when we get there. We'll also need to monkey with this prop C toolbox, because that's ultimately the last thing we need to do to make our blocks show up. But inside of generators, there's another folder here, prop C, and these are basically the files inside of this folder right here are the ones that define the blocks. So the analog IC stuff I would put inside of GPIO, and that's where anything dealing with like the input-output functionality of the chip. And that's where, for instance, some of our analog and A to D stuff already exists. So I'm going to open up GPIO here, and it's probably going to take a minute to there recognize that it's JavaScript. Let's give my code a little more breathing room here. Yeah, not that much breathing room. There we go. I still want to see what file I'm working in. So while this looks complicated, it's really not. So for instance, this is what defines a block, this chunk of code right here, and there are two pieces to it that you might notice. There is Blockly blocks. This is what actually defines the block itself. So for instance, this tells us what our help URL is, what our tooltip is, and these are in that language file I mentioned, what color the block is going to be. These next couple of things, like previous index, that tells us what shape it's going to have. There's also like a set output would be the other version of the block. And then where you start seeing appending dummy inputs or value inputs, this is where you see the meat of what goes on the block. And so that's how the block appears and how you interact with it. And then based on whatever happens up here, then we get values from, say, like whatever pin was selected by the user or whatever action was selected by the user. And then we do some stuff where you can see it's actually writing, like for instance, if they selected high, then it's telling it to write that from based on what the user put down above, so the drop down pin. So it's actually writing the C code, and you can see that, and then it ends it with a new line right there, and this is the definition. This right here is the generator for the block, and so that's the basic gist of it. And for the most part, our blocks, the ones we're going to build here, are going to be pretty simple, and so they won't even necessarily need to be this complicated. In fact, this is probably a good place to actually start. So what I'm going to do is I'm actually going to just copy these. And so let's do control or edit copy. Now let's go, we're just going to scroll all the way to the bottom of the file so we've got some room to work. And go ahead and put in something like a break here where it says my custom blocks. And the first thing we're going to need to do is we're going to need to actually change the name of the block so that it doesn't get confused, or that we're not redefining it from up above. So let's go ahead. We were going to build a block that allowed us to set this ADC, this AD5220, we'll say set. So that's going to be our block. It's going to be the basically the digital pot set. And now just to show you basically an easy way to build what a block looks like, go ahead and go to the internet and just with a new tab here, we're going to type in block factory. And you'll see, you scroll down this Blockly demo block factory. This is a tool that we actually use. It's a Blockly developer tool that allows us to build a block the way we expect it to see. And you can see the language code. We're going to change that to JavaScript. Now you can see that's actually looks pretty similar to what we have inside of our code here. It's designed to help you sort of get started and make this pretty easy. So we're going to say, we're going to give this the same name, 82522 set. You'll see that I put it right here. And we leave JavaScript for the generator stub because it's actually pretty similar to C. It's not terribly different. Let's go ahead and give this block a color. I know that most of the A to D functions are kind of in that vicinity. And the set color, we'll end up just copying the I/O, or actually what we'll do is we'll go up and see actually right above our custom stuff here is these other chips and the other A to D stuff. It's kind of fortuitous and lucky. I didn't intend for that, but there it is. And it's using this same get color I/O. And so this one's already set to get color I/O, so perfect. We're in business right there. And there are, by the way, there are 9 colors to choose from. And I think, if I remember correctly, they're defined in this propc.js. Might be mistaken. Okay, yep, here they are. So here's the default color palette, actually right at the top of that file. So you can see the names of each of the different ones, and it goes from a pretty close to green color and shifts all the way to a pretty close to red. In fact, I think it even goes as far as yeah, to a reddish color, red or even purple. And so these are the defined colors, and even though there's a bunch of them, you might notice that A, B, and System, for instance, have the same color. So, and I'm trying to think, yep, Robot and HEB also share the same color as well. So these are the different colors that are available. Well, let's go back to our GPIO file here and get our custom block going. So we want to first put in a dummy input. Actually, no, we want a value, don't we? So we want to do a value input, and see, this allows us to do this. And so we're going to say that our inputs are inline. Now we're getting closer. And that we have top and bottom connections. The field we're going to input here is set voltage. Now we want to set doesn't like potentiometer, does it? This is pretty wordy. We may actually just want to use no, I think set potentiometer too. So, and then the type, we want to restrict it to a number type. And that's basically our block right there. This has pretty much everything we need in it. And so this is the code. Let's go ahead and copy this, and we'll compare it to what we have inside of here. So if I do this. All right, so I'm going to go help URL. So analog and pulses, that's the same. Any help URL is going to be on that same category. Or what you can do for custom blocks, if you're not too worried about the help URL and that sort of stuff, is actually I'm going to delete this out because it's not going to be, we're not going to worry about the Scribbler 3 with this. Analog pulses. You can also just simply comment out these two lines, or you'll notice that you can fill them in with just text. So you could actually write out your help URL here if you want it in your tooltip. What we do is we have everything stored within this language file, so that when we get to the point where we can internationalize everything, then it would just be a matter of swapping out the language file, and then everything in there would change to whatever foreign language or localized version that somebody would want to create. So let's just say we haven't created this yet, but it would look like AD5220 set tooltip. So these would be the two things there. This previous statement, next statement, previous statement, next statement. This block here is not terribly important, and you'll notice that their version of it says null. The reason we put this here on the previous statement is it has to do with the it has to do with making sure that you can't put anything other than a function block inside of the new processor block. So you don't really have to worry about that one. And then append value input. Let's grab this and the inputs in line. Copy those. And we'll just replace what's here. Tab these ones over so that it's where it's supposed to be. And I think we got next statement, previous statement, just making sure everything lines up here, but I think we're in good shape. So the value input, let's give it, I'll just say pot value. Okay. So far so good. Now, get field value is good for drop downs or text boxes, but when it comes to getting a value, we actually need to do this a little bit differently. So I'm going to go find a different, we're just going to scroll up until I see a block with a value input. Or better yet, let me just hit find, and we'll just say value input. There's a lot of copy paste that goes on. So I've got a value input here and a value input. And here's how it gets retrieved in this block. So there we go. Let's go back to our stuff at the end now that we've copied that. And that's the only value we're getting. So let's delete that, and then there's kind of this series of order atomic, order none. This has to do with order of operations, and generally what you put in here is either going to be order atomic or order none. And what the difference between what you'll see is whether it's going to do something like wrap it in a parentheses or not, to make sure that the order of operations happens correctly if this is inside of another equation or something like that. And so for now we're just going to leave it, and then we're going to say if no value is provided, just set it to 0. And you'll notice that all we're doing here is just simply returning something. And so let's go back to our library that we created, and we have this nice set function here. So this is what we're aiming to get to. We're aiming to get it to generate this. And so far we just have the wiper value set. So let's go back here. Let's go ahead and just paste this inside of a string. We don't need int. So we do need to collect a few more pieces of information. We so far only have the wiper value, the pot value. Make sure these match up right here. Otherwise I'll get a little bit upset about that. We'll say pot val. And then what we do is we just replace this There we go. So far, so good. So we just need to collect the CS pin, the clock pin, and the direction pin. And so we'll go back to our block factory. And let's do this. Let's add a few fields. So we need to add some drop downs. And we'll say this is CS pin. Just for giggles. 3, 3. So that it looks like, you know, we'll fill this with something different here once we get there. Let's actually go back to our Blockly. Let's actually open up our own Blockly and compare like to how other pins look. So we're going to open up our own Blockly. Do a new project. The flip. Because that's got these cool Okay, so here we go. We're doing, you know, what it is, and we're reading it. We're saying chip read. Okay, so maybe what we'll do is we'll just say something chip set, and then we'll do each of the, what we've got is each of these things. Each of these pins is set to show us, like, for instance, clock will be abbreviated with CLK, or chip select is CS, direction will probably be DIR, or maybe the data sheet lists it as UD, like up down. So let's do that. So let's go back here and say AD chip. I'll just get rid of this for right now. Make this look the way we want. AD chip, and we'll say CS. That's the first pin. And the next pin was CLK, the clock. It's kind of cool to use Blockly to build Blockly. And up down is our last one. Up down pin. Okay, and actually my code refers to it as the direction pin, so maybe here I'll call it DIR. A little easier to remember which is which. And let's give it a little more text. There we go. 85220 chip, CS, clock, up, down, set potentiometer 2. Okay, so now you'll notice we've got a little more meat inside of this value input. So let's grab that. So we'll just copy it. Oops. And go back to our code to edit. We'll just replace the meat here. Alright, so why is this throwing an... Oh, wait a minute. Got an extra thing there. It's like I've noticed a whole bunch of this lit up red. What's going wrong? All right, and then let me tab these back over. So there we go. Keep my formatting nice and clean. And we actually have a pin definition. Pins are defined. So all of this right here, this whole array will get replaced. So if I scroll back up here to something else that has pins like that, you'll notice instead it's just got this profile default digital. And where that comes from is depending on which board type you are using, it states which pins are available. So I'm going to paste that in here. And one more. Okay. Now, how do I get those values? Remember that there is, under prop C, if I scroll up, there's just this nice get field value. In fact, here we've got a couple of them pretty much ready to go for us. So we'll just copy those from a different block and paste them in here. And so we have CS pin, we're good to go there. Clock pin, the only one we need to change is this dir pin. Now, that actually worked out really well. And I'm going to replace there, and copy, paste. Forgot which order these go into. Okay, the order was CS, clock, and direction. Okay, perfect. CS, clock, clock, and direction. Paste. Okay, so if we did everything right, this is our block. Now, let's go ahead and go to the Prop C toolbox and actually tell it that we want this block to start appearing. And where do we want this block to appear? Well, let's go ahead and take a look at what seems to be appropriate. We could create, actually under voltage here would probably be the most appropriate place for it. And so we're going to look for the analog pulses category and then a subcategory of voltage. So let's go ahead. This Prop C toolbox file is a bit intimidating. It's a file that has just a big string here, and you'll notice the string is long. So let's the block that was near that was the MCP. Okay, so now we're in business, and it appears that there's that appears in two places, and interestingly though, the way this is set up is it's set up for there's these excludes, and it excludes certain board types. So this one just sort of takes a little while to get used to. For instance, if I put it here, this is only going to show up in flip and other because that's include. Include the voltage. Here's the include for activity board. So this is the activity boards menu exclusively. So if we want it available for the activity board type, we'll have to add it within this category right here. If we want it available for the flip, then we need to include it within this category right here. Let's start with the flip, and then we can worry about getting it inside of other ones later. Now inside of, you'll notice that some of these have like a block inside of a value. Let's actually copy this AB volt out here, because I want it to come pre-populated with a block. So I'm going to put that in, and my block, if I go back to my block name, this AB5220 set, go back to the toolbox. Okay, so that's there, and this has, the next thing has to match. So pot value is the value input, and so inside of that value input, I want a math number block that just starts with the number 0. Okay, so far so good. So let's go ahead and save all. So now it's inside of there, and let's go ahead. You can right click, I can quit BlockyProp and start it back up here. Not sure why it's not letting me right click there. So I'm going to do a new project, propeller flip. It's bothering me that it's actually not letting me right click. Because if I want to see, if I want to inspect what's going on, then yep, that's definitely bugging me why that's not available, because if there's an error, it's hard to see it if we can't right click and inspect inside of here, so I'll have to figure out what's going on there. But let's go to analog pulses, voltage, and now this block is available. And so if I flip to the code view, you can see it's generating that block for me. And if I change each of these to, like for instance, if I've got it hooked up to pins 21, 20, 21, 22, and I want to set my value to 54, go to code, there we have it. And if I want to set this to the value of a variable, I should be able to do that. And there we go. All right, perfect. So it looks like we're missing something. We're not including our library, so this won't work just yet. Let's go back to our code. And in order to include a library, let's actually just search for #include. Here we go. You can see that there's this little chunk of code right here, this if disabled, include servo. I'm going to copy that, just steal that from a different block, and I'm going to put that inside my prop C here for this guy. What it's saying is, as long as the block's not disabled, to go ahead and inside of definitions. The nice thing is if you know what code you're aiming for, another code is probably doing something, another block is doing something similar. So this find becomes super helpful, and you can really do just basically a lot of copy paste. And my library, remember I went and I named it, oops, didn't mean to open that, but that's okay. I named it analog IC, so analog IC.h. So there we have it. That should give us that last thing we need. So we'll save all. Quit and go back to it. New project for the flip. Okay, let's see if it, there we go. So now that's added in. So this should function correctly for us. So let's go ahead and take this for a test drive. Let me make sure, since I fired this up already, we'll just connect that. All right, so far so good. And let's plug in my board. I think something's up with my computer, which might be why the issue is. I probably just need to get it restarted here. It's been running for too long. Ah, okay, so it's going to show up. Let's see what happens. So repeat item from, remember, 0 to 128 by 8. And we'll just use the item variable. I don't see any reason not to. Now I gotta remember which pins I had this thing hooked up to. So let me go back to the data sheet just to, so let's see, I want the data sheet for the AD5220 data sheet. Trying to remember, what did I hook it up to? So let's see, on my particular guy here, I've got clock on pin 1 goes to, so my clock is 1, my up down is 2, and my chip select is 3. I'm going to try to remember going back here. So chip select is 3, clock is 1, up down is 2, I think. Okay. So I won't worry about firing up the camera, but I will tell you if this works or not. Crossing my fingers here. Yeah, there's as much luck as anything I involved, I think, in sometimes making this stuff work. So let me go ahead and load that. Oh, unable to compile my project. So yeah, that's telling me I think I need to restart my computer because it was working just fine before. So tell you what, I'm going to end the video here since that was kind of a lot of information and download, and let everybody digest that, and we'll come back and hopefully find out if this worked or not. All right, thanks for watching.